is the shape of output? Shape is 1632, and this is what we have. So it seems like concatenation is working fine, and let's just try one more time. Let's just yeah, let's just do this thing. Tensor get out chunk, and this should be what out chunk. uh let's see now. Get to the out and get out. So let's see if our um, slicing and concatenation is working fine. Tensor get out chunk. Alright, so these are actually all the chunks. So how about this is actually a very important part of our development. So we need to ensure that everything works fine here. Alright, so first chunk was 4 7 8 and 6, and 4 7 8 and 6. That's good. And let's just see what the last chunk is. So the last chunk is 8 6 10 and 3, and where it is, uh 8 6 10 and 3, 8 6 10 and 3. So I think it's working fine. 1 6 7 8 1 6 7 8. So our concatenation and our slicing logic works absolutely fine, absolutely fine. So git add let commit dash m autograd modified tensor concat, working fine. Origin Autograd. Okay, so these two methods are working just fine, and now what we need to do is we need to come over here, MHA forward, and let's see what's going on here. Extract the required parameters. Okay, so right after this, what we have is should take number of heads. That's the question, because we loop like this for int k equals 0, k less than, let's say, num heads. And we find the chunks of these tensors. So let's say this is going to be tensor q k, and that is going to be tensor slice columns a, right? And then we have okay, so can we do it something like this? um takes actual tensor, then some q, and starting index would be k. And what is width? So we need to find dk, and the dk is going to be what? Dk equals embedding times number of heads. Embedding, let's just take it static for now and we'll change it later. So embedding size is, we know, 32 divided by 8, and so let's say int dk is equals to 32 divided by 8, and let's just pass this over here, dk, and same we're gonna do for other two. I think values, we are not gonna replace the values. Okay, so here what we have done is, yeah, we need to do it for all of them, so yes, and then we have sliced them, right, and then we need to find attention, scale dot product attention, right? So this is going to be tensor score, and this is going to, let's say head score would be scaled attention, and this is going to take let's say arena. QKV and DK, right? So QK, right, there you go. And then what happens? And then we put them back all, right? Alright, so let's see. So first we need to store them in some array, and this array is going to be our array like this. Head array equals to arena number of heads. Do we have number of heads times size of tensor pointer, like so. And this should also take number of heads. Let's just change this as well. Okay, we'll change this later. Let's see if this works first. So embedding dimension 32 and 8, and like so. And then we need to populate this array, and this is going to be like array not k will be, I think, head score. Okay, looks good. Okay, and now we are going to loop and populate MHA out. So or can we just use this while over here, which we've already written, like so. we can do this entire thing inside this loop. Oh yeah, we don't need to actually do this. We can do this at the same time. So heads array k is equals to head score. That's right. And yeah, we need to have one loop extra. While k is the number of heads. And no, we don't need slicing logic. Instead, we need concatenation logic. Tensor C. Okay. Concatenate. Okay, so concatenate heads A. Okay. We just wrote this function and we kind of forgot what was the parameters. So yeah, that's all happens all the time. So forward and yes, just pass it over here. Image out would be white. Tensor concat arena heads array and white. Number of heads. Okay. Fine. And just return this. No, we need matmul operation as well. So let's just see what's the shape of this now. And tensor uh, tensor get 2D, and this should return null for now. And this is what's going on here, what's going on here. MHA create. Okay, do we have something called we need to test whether this forward pass is working correctly. And how are we going to do this? So MHA init params mh initialize parameters and what it takes tokens. It should take arena as well. Arena we do have heads here. Okay, let's just see what do we have here. So to tension 2.h. So we have we don't have yeah we have heads in DK. Yeah, so we have heads in DK. Let's not do them over here. Instead we can use from MHA. So what is K and this is like MHADK. DK and this should also be MHA. So and where's number of heads? Number of heads. So I think it would be somewhere here. MHA number of heads, and let's just name this as well. So MHA number of heads. So far so good. And yeah, so we have heads, we have head dimension, and we are passing them over here. Initialize parameters. So we have a, and what is tokens? Tokens is tensor create new. Shape of tokens, and let's just not call it token, instead tensor x, right? And heads, this is our dk. Oh, okay. So we have function called mha create new, and let's just see what it does. Does it create dk for us? Yes, it does. It does. So we don't need this, right? We don't need this head dimension either. uh, okay, mha create new, and what it takes: arena, heads, sequence length, embedding dimensions. So arena, just take heads, sequence length, embedding dimension, initialize parameters. This is x. Yeah, let's see what happens. So okay, so let's just change our run file now. So arena llm dot c, number of heads undeclared. This is heads actually. Let's just call it num heads. Inside forward we have what? MHA number of heads. We can also extract these values from MHA first. This will be a lot more readable. Alright, so tensor slice column implicit declaration. Did you mean tensor expand columns? Tensor slice columns. No, I mean tensor slice columns, and it is written over here, but what is wrong? Why is it not, like, why is it calling it implicit declaration? Hmm, let's just see the run file. So run has all these things changed, arena, attention to, and everything. Run has all these things, right? And tensor slice columns. Arena, tensor k, and dk. So are you serious? Okay. Okay, in DK, heads array undeclared. Okay, heads array is undeclared. Let's see. Uh, Heads array. Undeclared A. Ooh, yeah, we haven't declared arena over here. And dimension redefinition. Heads. Heads undeclared. It should be num heads, I guess. Too few arguments. Ah, it takes MHA. Tensor shape. Oh, yeah, I mean 2D. Multiple definitions, that's correct. Let's comment. Whoops! Boom! Something is wrong. We're getting none values and zeros, right? So it means that we are able to run successfully our MHA multi-head attention forward function because we are getting the dimension. We're getting something at least, but we're also getting segmentation fault error. So we'll have to check what exactly is wrong. And yeah, I think it's good that we're still getting something. We'll check this later and we will resolve this in the next one. See you then.